All right, Chapter 3, review question number 2, has this system with a combined mass, one resting and one pulling down with the force of gravity to accelerate it. It says, at what rate will the system accelerate? Assume no friction. So this must be like an air table or an icy surface or something like that. We're going to then consider two free body diagrams. That's a good start for any question. We have the 0.8 kilogram mass, which has the tension acting on it. And we have the 1.2 kilogram mass, which has the tension and the force of gravity acting on it. I can put the normal force in here too, I suppose. Fn. If I was drawing free body diagrams, I wouldn't want to forget it. But in this instance, it's not important because there's no friction. So we can then say that for this mass 1, let's call this mass 1 and this mass 2. We could say that M1A is equal to tension. The tension being the force that is able to accelerate that. This is why it is equal to F net. For this next one, F net for mass 2, it is equal to Fg, or M2G, minus T. Makes sense? And I should have said this one was equal to M2A. So M1A is T, and M2A is M2G minus T. These are the two formulas that we're going to combine. So M1A and M2A. Let me just fix that here. So M1 plus M2, all multiplied by A, is equal to M2G. Now, you see that if you cancel these tensions when you add those. So, a bit of rearrangement then. M1A and M2A. This is 2 kilograms times A is equal to M2G, which is 1.2 times 9.8. Rearrangement, A is equal to 1.2 times 9.8 all over 2 gives me an acceleration of 5.9 meters per second squared, downward obviously. Okay. It says what is the tension in the line for part 2 there. For here, we would return to our previous formula, which was that M1A is equal to tension. Tension is equal to M1A. So M1 is 0.8 and A is 5.9. 0.8 times 5.9 is 4.7 newtons. I just want to show you that it could have worked the other way too if I had used the formula that said tension. So I'm looking at the previous example, tension here. Tension in that example would be equal to M2G minus M2A. M2G minus M2A. So if I had chosen the other formula, M2G 1.2 times 9.8 minus 1.2 times 5.9, I would have got the same answer of 4.7 newtons.